we're going to go over section 2.1 today. Just have one example set up to go through in this video. You've got other examples in your book. You can also ask questions in class. Here we want to construct a frequency distribution and frequency histogram for the following data set using 5 classes. And we want to make sure to include the class, class boundaries, frequency, midpoint, relative frequency, cumulative frequency in that frequency distribution. So first of all, I've got the list here of all of our values. So the first step of what we're going to want to do here is relist them in order. So make them from smallest to largest. That's normally what you'll want to do. So I already wrote those down here. So that would be your first step you'll want to do. Keep in mind whenever you're doing these problems on your own, on a quiz or test, or whenever you're doing the work in class, you'll have to go through and do all of this setup on your own. There's not going to be the table already there or anything, so you want to make sure you remember how to set this up. Be a good idea to make sure that you're taking notes with this as we're going through these. So after you get those listed in order from smallest to largest, you'll want to figure out what to use for your class width. So just like it has in the book there, to find that, you're going to want to do your range, which is your highest minus the lowest value, divided by the number of classes. So in this case, our range to calculate that, we'll have to do the highest value, which is 60, minus the lowest value, which is 20. Let's subtract that. I'm going to put that in parentheses since we want to make sure that we subtract that first, and then divide the answer by the number of classes. In this problem, if you read the directions again, we said to use 5 classes, so we'll divide it by 5. So if you calculate that, we get 40 divided by 5, which equals 8. One thing to keep in mind here with your class width, if it ends up being a whole number, you'll want to round up to the next whole number. If it ends up being a decimal, you still round up to the next whole number. So always keep in mind that here you want to round up to the next whole number. So in this case, you're going to round up to 9. So we're going to round up to the next whole number. The reason for that is to make sure that we have all of our values included, because whenever we're setting up our classes here, to make sure that they're all going up at the same amount each time, that we don't have more values in one class than the other. So in the table here, to start out our classes, we always want to start with the lowest value, which is 20 in this case. And then we want to set up our lower bounds. Normally it's easiest to do next. So the lower bounds are the smallest values in each of these intervals. So to get to the next one, we add 9, since that was our class width. So our next one would be 29. And then 29 plus 9 would give us 38. If we do 38 plus 9, we get 47. And 47 plus 9 gives us 56. So that would be for the lower bounds of our intervals here. And then to get the upper bounds, so the upper values in each of these intervals, to start out with here, we'd have 28 as our first value, because it needs to be one less than whatever that next lower bound was. So that way we're not overlapping our intervals at all here. Here we're assuming that we're using whole numbers, which is what our case is going to be for these examples. Our next one here then would be 37. So it's one less than that 38, which is the next lower bound. Then the next one would be 46. And then 55 from there. And then for that last one, since there's not another lower bound interval, we're going to have to add 9 to that 55 to get where that ends. So you don't always end it at the maximum value. You have to add it at whatever 55 plus 9 is. So if you do 55 plus 9, we get 64 there. So next we want to do our class boundaries. So I'll slash for that here. So for our class boundaries, we just go down 0.5 from our lower class limit and up 0.5 from the upper class limit for each of these values. This will be used more later on, but just so you have an idea of how to do this for future reference. So once again, you go down 0.5 from the lower class limit, and then up 0.5 from the upper class limit. So that way you're including all those values plus just a little bit more. It's also a way that you can use for doing your histogram, which we'll get to here in just a little bit. So you go through, you fill in those values. You'll notice once you do that, that there is no longer a gap in between each of your intervals. So that way all the values are included now. The next step is your frequency. Frequency, like it sounds like, you're just counting to see how many values are in each of those classes. So if we look once again here at our first class here was 20 to 28. So we have to count up above how many of our values were between 20 and 28 inclusive. We want to include those endpoints as well. So if we count for that first one, we have 20, 22, 24, 25, and another 25. So we have 5 values there. And then do same sort of thing for each of those. And next one, you should have 4 in there, 6 in that next one, 2, and then 3. So once again, to get those values for the frequencies, you're just counting to see how many values from your list you have in each of those intervals. For your midpoint now, just like it has in the book, to find that midpoint, you're using the lower class and upper class limits that you have there. So in that first class, we have 20 and 28. So we have to add together those two numbers and divide it by 2. You can think of it as doing the average of that lower class and upper class limit. So here in the first case, we'd have a midpoint of 24. Once again, we can write in parentheses after that. That was from doing your 20 plus 28, and then dividing it by 2. So doing the average of the lower class, upper class limit, and then dividing it by 2. So that's how we got to that value of 24. And then you do same sort of thing for each of those midpoints. Or the quicker way there, once you have that first midpoint, you can add your class width to get to all your other midpoints. So as long as you got your classes set up right, to find your midpoints, you can just add your class width of 9 to get to each of those other midpoints. And make the calculation a little bit quicker there. So I'd have 33, 42, 51, and 60 for the midpoints there. Next we have our relative frequency. To find the relative frequencies here, what we have to do is we do the frequency, so in this case was 5, divided by the total of all of your frequencies. So in other words, what you get whenever you add up those frequencies, which is also the same thing as however many numbers you had to start out with. So in this case, we had 20 values, so we do 5 divided by 20. So to get that relative frequency, we divide those. So if we do 5 divided by 20, we get 0.25. And that would be our relative frequency. And then you do the same sort of thing for each of those. I'm not going to write out the fraction for each. But in this case, you do the 4 divided by 20 to get 0.2. You do 6 divided by 20 to get 0.3. Next one, you do 2 divided by 20 to get 0.1. And then 3 divided by 20 to get 0.15. And then the cumulative frequency, you can think of like your cumulative grade in a class. It's adding up what you have to that point. So the first cumulative frequency is just the 5. The next one, you have to do the previous frequency of 5 plus 4. So we'd get 9. And then you have to keep adding up the next one. So now we do the 6 plus the 4 plus 5. So there we'd get 15. And then we'd have to add another 2 to that to get to the next cumulative frequency, since our next frequency was 2. And then we'd add 3 to get to the last one. So your ending cumulative frequency should always add up to whatever you had for the number of values in your data set to begin with. So that's what you would do there in order to come up with the frequency distribution. Keep in mind, not all frequency distributions will require all of that work. Just depends on what the directions say. So you want to make sure you're keeping an eye on those directions, so that way you're not doing more work than you would need to do for that particular problem. So then for the next part, for our frequency histogram, what we can do is use that table that we just set up to come up with our histogram. So first of all here, for our labels off to the left side here, what we have is we have our frequency listed over here. So we'll abbreviate that FREQ for frequency, or you could label as F for frequency since that's a common abbreviation there. And then normally what I'll use here are your midpoints. You could also use the class boundaries if you prefer, like they do in the book. They show both ways in the book. It doesn't matter to me which way you do it, just make sure that you're labeling what you're using there. And then for our frequencies here, we don't have very high for our frequencies, so we could just go up by 1 for our scale here. So you want to make sure that you're marking that out whenever you're doing this. Looks like our highest frequency was 6, so we'll want to make sure we go up at least 6 marks. We want them to be pretty even whenever you're sketching these. Not going to be perfect. We're not using graph paper here. And then for our classes here, once again, we're using our midpoints. So our first midpoint here was 24. And each of these are the same width apart. So we'd have 33, 42. They all had the same class width, so they're all the same width apart here. The only thing we want to make sure that we are accounting for here is this gap between the 0 and the 24 here. We did this little squiggle type symbol here to represent that as your break. Or you can think of it as a jump in the numbers. It's separated from 0 to 24 there. So as a jump of 24 rather than a jump of 9 like all the rest. So you need to insert a break anytime that jump is different than the rest of your scale there. So again, here for our frequencies, we're going up by 1. For your histogram, it looks just like a bar graph. Only difference is that for a histogram, each of your bars are connected. You can also see that with your class boundaries because there's no gap in between your values there. So we're going to connect those bars together, and they should be approximately the same width as each other. And the heights of those bars are going to correspond to your frequency. So for instance, that first one, we had a frequency of 5. So we'd go up to 5, over and down. The next one had a frequency of 4, so we'd connect right from that last one to 4, and then over and back down. The next one, the midpoint of 42, we had a frequency of 6. So I go up to 6, over and down. And then we'd have 51. That one had a frequency of 2, so we need to go up to 2, over and back down. Same sort of thing for the 60. There we had 3, so we go up to about where 3 would be, over and back down. And then that's what we'd have for our frequency histogram there.